explain about a project titled DFR TSD, a deep learning based framework for robust traffic sign detection under challenging weather conditions. So now coming to the introduction part. DFR TSD also demonstrates high flexibility and generalization, making it suitable for integration into existing traffic sign recognition systems. Its ability to perform well under challenging weather conditions makes it a promising solution for enhancing the reliability and robustness of traffic sign detection in real-world driving scenarios. As a result, DFR TSD holds significant potential to contribute to safer and more efficient transportation systems, reducing accidents and improving overall road safety for all road users. At the core of the DFR TSD framework lies deep learning technology, which leverages convolutional neural networks, that is CNN, to process and analyze traffic sign images. These CNNs are trained on extensive datasets that include various weather conditions, enabling the system to learn and adapt to different weather-related distortions and obstructions. So now coming to the objective part of DFR TSD is to contribute to safer and more efficient transportation systems. By mitigating the effects of challenging weather conditions on traffic sign detection, the framework seeks to reduce accidents and enhance overall road safety for all users, making significant strides towards a more reliable and sustainable future of transportation. By leveraging the power of deep learning, specifically convolutional neural networks, DFR TSD can effectively learn and adapt to different weather-induced distortions and obstructions in traffic sign images. Through extensive training on diverse weather datasets, the framework aims to equip itself with the ability to extract meaningful features and relevant information from traffic sign images, even in poor visibility conditions. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirements. In hardware requirements, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDEL, that is 3.7 version is required. So now coming to the methodology part, first we have generate and load traffic sign CNN model. To generate and load a traffic sign CNN model, first you need to design the architecture of the convolutional neural network suitable for traffic sign detection. This typically involves selecting the appropriate number of layers, types of layers, activation functions and output layers for classification. Second, upload test image and clear. To test the traffic sign CNN model's performance, you need to upload a test image containing a traffic sign. The test image should be clear and representative of real-world conditions to assess the model's accuracy under various scenarios. The test image should be in a format that the model can process, such as JPEG or PNG. Third, detect sign from clear image. With the CNN model loaded and the test image uploaded, you can now pass the test image to the trained CNN model for traffic sign detection. Fourth, propose CNN training graph. A CNN training graph illustrates the architecture of the CNN model and its flow during the training process. It typically includes the input layer, hidden layers, output layer, and the connections between them. Each layer represents a different set of learned features, and the connections denote the flow of information during forward and backward passes through the network. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder named as PyCatch. In this we have a Python file containing the Python script in it. This folder annotations containing the training dataset. And in this folder dataset, it is containing a folder named as data, which are containing the two data folders containing dataset in it, that is clear in here. And we have a folder named as model. In this we have .h5 files which contain the deep learning algorithms information. These .h5 files can be loaded into the project code during runtime to utilize the trained model for various tasks, such as making predictions on new data or performing specific operations. Now the folder test images containing some images for testing. And the folder for train have some folders which are containing images in it. The data reader file and the main file are the Python files which are containing the Python script in it. Here this is the main Python file. And this is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. Now to run the project, double click on run.bat file to execute the project. Here this is the graphical user interface. With this we are interacting with the program. Now click on Generate and Load Traffic Sign CNN Model button to generate and load CNN model for getting the output. Here you can see CNN model loaded. And now click on Upload Test Image and Clear button to upload the affected test image and clean it. So now here I am selecting this first image and click on Open button to load and clean image for getting the output. So here in this screen, first image is the weather affected image, which can be from cloudy haze, rain or bad light or bad camera lens. And second is the clean image, and you can see the difference between both images. And now closing this image, click on Detect Sign from Clear Image button to get the output. So here in this image you can see CNN model detected traffic sign and put boundary box around it. Now we can test with another image. Click on Upload Test Image and Clear, and now select this image. Click on Open button for getting the output. So here first image is the weather affected image and the second one is the clean image. And now closing this image, click on Detect Sign from Clear Image button to get the output. So here in this image, traffic sign detected, and similarly you can upload and test other images. Now close this image and click on Propose CNN Training Graph button to get the output. So here in this graph, x-axis represents training epoch and y-axis represents accuracy and loss value. And here green line represents accuracy and blue line represents loss. In this graph we can see with each increasing epoches, accuracy got increased and loss got decreased. Note, no detection algorithms are accurate, so some bounding boxes may not predict accurately. Now simply close this graph. Coming back to the conclusion part. In conclusion, DFR TSD represents a groundbreaking deep learning based solution that can significantly improve traffic sign detection, accuracy and reliability under challenging weather conditions, making substantial strides towards safer and more resilient roads for everyone. As the transportation landscape continues to evolve, DFR TSD's robustness and reliability offer a proactive approach to address the challenges of adverse weather conditions, providing a key building block in the development of safer and more efficient transportation systems. This ability ensures that traffic sign information is promptly recognized and conveyed to both autonomous driving systems and human drivers, thus enhancing overall road safety and efficiency.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.